In section 8.2, we're going to use proportions in problem solving and geometry. We have some properties of proportions that we talked about in section 1, and we're going to add a few properties to those. So if we're given A over B equals C over D, then we know that we can multiply the extremes and multiply the means, and those two are equal. So A times D is equal to B times C. In addition to this, the means can actually be reversed. So instead of A over B equal to C over D, you can actually reverse the means because they're going to be multiplied and write that A over C is equal to B over D. We also talked about a property that says that if we have a proportion to ratios that are equal, then their reciprocals would also be equal to each other as long as you do the reciprocal of both. Therefore, B over A is equal to D over C. Our fourth property lets you add the denominator of each ratio to the numerator, and the proportion remains equal. So again, we were given A over B equals C over D. Therefore, A plus B over B equals C plus D over D. Let's look at some examples that apply these four properties. If we have x over y equals 5 over 2, and it may help you as we take these notes to make sure you have these written as fractions so that you can easily see circles. If we get 5y, that's equal to blank. Okay, so looking at our proportion, 5y would be the means multiplied. That would be equal to the product of the extremes. So that would equal 2x. Number 2, x plus y over y, we're adding the denominator to the numerator. Therefore, we would get 5 plus 2 over 2, which is 7 halves on the other side. Number 3, 2 over 5 is the reciprocal of the second ratio in our proportion. Therefore, we should do the reciprocal of the first one, y over x. Number 4, x over 5 equals blank. What's happening is this is the property that reverses the means. Now the 5 is underneath the x, so the y will be over 2. So we're just looking at applying these properties and being able to use them and understand how they work. Next, we're going to use proportions to solve problems. We're going to be given some side lengths for this triangle. So we have a triangle, and we have another side that's being drawn in. This is BC. And we're told that the length of AB is 16. So from here to here. The length of BD is 8 from here to here. AC is 20. And we want to find CE. Now we know that the sides of this triangle are proportional. So we're going to say that AB over BD, if I take the top part of the left side over the bottom part, that would be equal to AC over CE, the top part of the right side of the triangle over the bottom part. And we're going to use this to solve. So AB is 16, BD is 8, that's equal to AC is 20, and CE we don't know. There are multiple ways to solve this. We could simply cross multiply, but we could also reduce this fraction on the left first to make it easier. 16 over 8 is the same as 2 over 1. And if you didn't see that, when you multiply, you will get the exact same answer. But now we have smaller numbers to work with. So we're going to multiply our extremes. 2 times x is 2x. And our means, 1 times 20 is 20. And when we divide, we find that x is 10. So the length of CE is 10. Same example, again, we have the proportion AB over BD equals AC over CE. And they're going to give us some parts. So this side AB, this is 6. AE is 15. AC is 8. And we need to find BD. So again, we're going to set up our proportion. AB which is 6, over BD is X, AC is 8, and then we need to actually find CE. If the whole length of this side is 15 and the top part's 8, then I know that CE is 7. Cross multiplying, I'm going to multiply my means first just because that's where X is. So 8X equals 6 times 7 is 42. To solve, we'll divide by 8. 8 goes into 42 5 times. That gets us to 40 with 2 left over, but 2 eighths is the same as 1/4. So the length of BD is 5 1/4. The other thing we're going to do with this section is we're going to be finding geometric mean. If A and B are positive, then to find the geometric mean, we'll call that M. We take the number A over the M is equal to our geometric mean M over B. For example, if we have the numbers 5 and 20, then 5 over the geometric mean equals the geometric mean over 20. So let's see what happens when we cross multiply. 5 times 20 is 100, so we're multiplying the two numbers together. M times M is M squared, and we're always going to get M squared. So then we take the square root to get rid of the squared, and the geometric mean is 10. So every time we go to find the geometric mean, we're going to actually multiply the two numbers together. A number that makes this proportion true is to multiply the two numbers together and find their square root. So the geometric mean of 1 and 9, the mean squared is 1 times 9. So we'll do the square root. And the square root of 9 is 3. Positive or principal answer. The geometric mean of 3 and 4 then, again, we're going to take the square root of the two numbers multiplied together, so the square root of 12. And we're also going to be simplifying the ones that don't come out nice, so we'll do our factor tree. We had a pair of 2's and a lonely 3, so the geometric mean is 2 rad 3. The geometric mean of 6 and 8, so the square root of 6 times 8 is the square root of 48. Again, we're going to do our factor tree, so I'm going to go off to the side and do my factor tree. This is 3 and 16, but 16 is 4 and 4. So we have a pair of 4's and a lonely 3. So this is 4 rad 3. So you need to know the geometric mean is the square root of the two numbers multiplied together. We'll be working on page 468 to 471, numbers 9 through 28 and 47 through 56.